A unit cube, each side of the cube has side length 1, is inscribed within a sphere such that each vertex of the cube lies on the sphere. What is the volume of the sphere? So if you can picture a sphere that is circumscribed about this particular cube over here, so this is the unit cube, and each one of the 8 vertices, here they are, 1, 2, 3, 4, 5, 6, 7, and then number 8 is back here. He's hiding. All 8 of those vertices lie on the sphere. So the sphere is just slightly bigger than the cube. And we know it is a unit cube, and because it is a unit cube, we know that this side right here is length 1. This side is length 1. In fact, they're all length 1. So what we'd like to do now is we'd like to figure out the volume of the sphere, and the formula for the volume of a sphere is 4/3 pi r cubed. So in order to use that formula, we need to know the radius of the cube, and we have something that's very close to that. We do have the diameter of the cube, because if you take any line that connects, and I'll draw one such line here, connects one of the vertices, here's one of them, with its opposite vertex, which is the one that's over here, that right there will be the diameter of the cube. So if you take half of that diameter, then what you have is you have the radius, and then you can plug into the formula. So one way of figuring out the length of this diameter is to first figure out the length of the line that's diagonal on one side of the cube, connecting these 2 vertices right here. So by Pythagorean's theorem, if this side is length 1, this side is length 1, and we have a right triangle, and there is the right triangle, then we know that 1 squared plus 1 squared will give you the length of the other side squared. So we're letting x be the length of this side right here, and we know that 1 squared plus 1 squared is equal to x squared, and when you take 1 squared, which is 1, and 1 squared, which is 1, add them together, you get 2. And when you solve that equation by taking the square root of both sides, you will get x is equal to the square root of 2. We do not need a plus or minus in this particular case because we're talking about a length here. So that side right there has a length of the square root of 2. But now we have another right triangle, if you look at this correctly, and that right triangle that we have has one leg that is right here, another leg, which is right here, which means there is a right angle between the 2 of them, and finally a hypotenuse, which is right here. And why don't we call that hypotenuse D? Because that is the diameter of the sphere. So once again, you can apply the Pythagorean theorem, and you have 1 squared plus the square root of 2 squared is equal to d squared. So let me write that down. 1 squared plus the square root of 2 squared is equal to d squared. 1 squared is 1. The square root of 2 squared is 2. That's equal to d squared. So 3 is equal to d squared. When you take the square root of both sides, you get the diameter of the sphere is the square root of 3. Now, if the diameter is the square root of 3, then we know that the radius will be half of that, so the radius is the square root of 3 divided by 2. Finally, to come back and return and answer the question, we have the radius. We're now looking for the volume. So this is the correct formula right here to plug into. And when you do so, the volume will be 4/3 pi multiplied by the square root of 3 over 2, which is the radius, cubed. So we get a 4 and a pi and a 3 times the square root of 3, all up in the numerator. So those three, or those four elements, here's the 4, here is the pi, and then the first two of these square root of 3 that gets multiplied by one another, they give you a 3. The third one gives you a square root of 3. Then down in the denominator you get 3 multiplied by 2 cubed, and 3 multiplied by 2 cubed is 8. So you can see that we can cancel here. This 3 right here cancels with this 3 right here, and also the 4 and the 8 give you a 2 in the denominator. So what you wind up with is pi over 2 times the square root of 3. Now, if you want to know exactly what that volume is, you could put that into a calculator, and at least to 3 digits, this will be 2.72 for the volume of the sphere.